This video is on geometric similarity. So the word geometric here means talking about shapes. Similarity stems from this word similar or alike. So geometric similarity is talking about when shapes sort of look alike. Two shapes are similar when they look the same, except for one of these things might have happened to them. One image might look rotated or turned compared to the other one. One of the images might look reflected, sort of the way when you look at the mirror, you see a reflection. One of the image might look like you zoomed in on it and made it look bigger, or zoomed out and made it look smaller. Let's give some examples here, or let's look at some examples of geometric similarity. Here, all these pictures, all these triangles, they're all similar. And when I mean they're all similar, let's look at these two. So compared to each other, it looks like this picture right here, this triangle right here, could be the same as this, just zoomed in. Sort of like the way you do in your camera, and you make it look bigger by zooming in. So these two shapes are similar. One of them just looks zoomed in, or the other one looks zoomed out. These two triangles right here, they're the same, except one of them is a reflection of the other. If we put a mirror right here, and one triangle was looking in that mirror, it would see that other image. Looking at these two triangles right here, they're also similar. It just looks like this one on the bottom is that same one on top, but rotated 90 degrees to the left, or 90 degrees counterclockwise. This one is also similar to this. It's just that we did a couple different things. It looks like a smaller version of it and may have been rotated or reflected. So all these are examples of shapes that are similar. If we wanted to go to a more precise definition for geometric similarity, two shapes are similar if their corresponding angles are equal. This is one of the defining characteristics of what it means when shapes are similar. So if we were looking here, let's look at these four triangles right here. Let's call this angle X. So this angle here, X. If you notice, all the other of these four triangles have a similar angle. Specifically, let's talk about these two. So that angle X right there, if we're looking at the smaller triangle, it is right here. And it has the same angle measure. And then this angle over here, which I'm going to call Y, it is the exact same size as this angle right here. And this angle here is the exact same measure as this angle here. So all four of these triangles are similar because they all have the same angle in the same order. I'm going to quickly label these same ones. So that angle Z is right here, the angle Z on this tiny one down here. x and y. So one way of defining similar are shapes that have angles that are equal, corresponding angles that are equal. All right. Let's quickly go and talk about some notation or how you write stuff. This symbol right here is the symbol for similar. This symbol right here is the symbol for triangle. Let's label our two triangles. I'm going to call this triangle I'll call this triangle A, B, C. So A, B, C are the corners of this triangle. And I'm going to call that triangle ABC. If I wanted to, I could have also called this ACB or CBA, whatever. When naming a figure, you just start on one corner, any corner that you pick, and you either go to the left or you go to the right. So you can go CAB if you're going to the left or counterclockwise, or CBA going clockwise. All right, and this other triangle, let's call it D. So I'm going to label these corners for this triangle. I'm going to label that D. This over here will be E. This one over here will be F. Okay, so if this symbol right here is the symbol for similar, this symbol right here is the symbol for a triangle. And I was trying to say that these two triangles right here were similar to each other. I would write something like this: triangle ABC, or this triangle right, the big triangle on the left, is similar to triangle. And here, when I name this triangle, I need to put it in sort of the same order as this triangle. So which letter on the little triangle corresponds with this A right here? So the A on my big triangle matches this corner over here, that is E. So first letter is going to be E. Okay. Then which letter matches this middle letter, B? Well, on the big triangle, B is this one right here, and that matches this F. So that letter is F. And finally, C on the big triangle matches D on the little triangle. So I would say triangle ABC is similar to triangle EFD. All right. So yes, make sure when you are writing that two triangles are similar, you are matching the vertices, or you're matching the corners. Let's continue. So we know that a triangle is similar if their corresponding angles are equal. If a triangle is similar, one of the properties that it will have will be that corresponding sides of similar shapes will have the same ratio. A ratio is, you can think of it as a fraction, or a relationship. So the relationship between the sides for one of the shapes will equal the relationship for the sides of the second shape. Let's give an example here. So all right. So this triangle on my left, the big triangle, the side 12 divided by this side 10 will equal the same as its corresponding sides on the other triangle. So this 12 matches this 6, and this 5 and this 10 here matches this 5. So I can make this fraction of the 12 over 10, and it will equal the same fraction over here made with its corresponding sides, or the sides that match the 12 and the side that match the 10. So these two are equal to each other. If you put in your calculator, 12 divided 10 is 1.2. If you put in your calculator, 6 divided 10 is 1.2. They're equal. And I could do that with the other sides as well. This 12 over this side on the right, 12, 6, matches the ones, will equal the ones on the other triangle in the same spot on the fraction. So each one of these fractions is a ratio. It is the relationship between one thing and another. This 6 and 3 right here is the relationship between this side of the small triangle to this side of the small triangle. Okay, and let's make one more. This 10 over this 6 is equal to the corresponding sides on the little one. So the 5 matches the 10. This 3 matches the 6. All right. And so here are 3 of the ratios. There's actually 3 more. I can, for each one of these pairs of fractions, I can flip them around. Like for this one, I could have had the green one on top and the blue one on the bottom. So there are 6 total ratio pairs. So you can write these 6 ratios for the corresponding sides. All right, and let's do a quick review of a little bit of basic geometry. I want to talk about the notation, or how you write a side length. Okay, so if I wanted to talk about let's say I wanted to talk about this length right here, from here to here, what I would do is I would write that as AB, and then you put a little line on top of it. So that right there means the length from point A to point B. And that is equal to that is also equal to me doing BA. Because the distance between A going to B and B going to A is the same. All right. Now, let's say that I wanted to talk about the angles. So an angle is the distance between one of these lines to another one of these lines. So, example, the distance from here to here, that is an angle right there. This right here is a symbol for an angle. And if I wanted to talk about this angle right here, if I want to talk about that angle right there are a couple different ways I could do this. I can write this as angle B, or I can write this as angle ABC. And when I say angle ABC, it's basically me showing that if I start here at A and I go to B, and then I go from B over to C, that the angle is the one in between those two line segments. That's the one I'm talking about. And I could also go CBA for similar reasons. This is the angle in between CB and BA. All three of these things mean the exact same thing.